So I'm going to explain addition law, and addition law in this case is the probability of A or B since a U, if it's upwards is an OR, and if it's downwards is an A, is an N, and the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A or B. But if it's in case it is mutually exclusive, it's like if there's a family, you can't be the first child and be the middle child. You just can be one of them. So like that's like mutually exclusive. And if it's mutually exclusive, it will be the probability of A or B is equal to the probability of A plus the probability of B. You do it that way because in here you're subtracting the probability of them both happening at the same time.
Multiplication law is different than addition law because you have here, instead of union, which is the U like this, you have an intersection, which is the U like this. And intersection means that both A and B have something in common. And there are two types of multiplication law. You have the independent event, which is the probability of A intersection B is equal to P of A times P of B. P is probability. And then you also have the example of independent events, which is the probability of A intersection B, which is equal to the probability of A times the probability of B given A. It means that, for example, you have the Gomez family, and inside the Gomez family you also have the Gomez Salazar. So it is a given you have all of the Gomez, which are Salazar, which is inside of.
So our problem says that we have 100 students they were asked the math class they enrolled, and it was found that 58 take statistics, 48 take calculus, and 8 take both. So we're gonna place the ones who take statistics. We're gonna put 50 because the ones who take both are 8. So on both we put 8, and since in calculus there are 48, we're gonna just put 40 on only take calculus. And after that, we're gonna place a formula to get the taking statistics. And since there are 100 students, if we add all these numbers together, it gives us 98. So we're gonna have to put the ones who take none, which is 2. And after that, it's telling us on letter 8, the taking statistics or calculus. So both of all those people who take it. So we're gonna put 100 over 50 plus 100 over 8 plus 40, and then 100 on the bottom. This answer will give us 100 over 98. And so we're going to put up here, P is S, because it's statistics, or calculus, and the answer is 98 over 100. This we have to simplify it, and if we simplify it, it's going to be 49 over 50. And this will be our final answer. Letter B is telling us to get the statistics or none. And we can now see that the ones who take statistics is 58, including the ones who take both. So it's going to be 58 plus 2, which that would be 60. So our answer is going to be 60 over 100. And of course we have to put P, S, or N equals this. And our simplified answer is going to be 3 over 5.
Okay, by the precondition, taking statistics given enrolled in calculus, what this means is probability of calculus given statistic equals out of calculus, it's 40 plus 8, it's calculus. And among those 48, how many are taking statistics also? And that number is 8, so it is this. And if we simplify, it is 1 over 6. It's 100 in 3 out of 8 tests, and Daniel gets 100 in 2 out of 6 tests. And problem A is the probability, find the probability of both getting 100. And from this, we have to get the probability of both getting 100. And how we calculate that is by multiplying the probability of Khan getting 100 and also Daniel getting 100. So this is, Khan gets 3 out of 8 and Daniel gets 2 out of 6. And if we multiply this, it is going to be 8 out of 1. 1 out of 8. And this is the probability of both getting 100.
The next problem is the probability of not getting 100. So what we are going to do is grab the remaining probability of each of the fractions. So in Khan's case, instead of using 3 over 8, we're going to use 5 over 8 because that's the remaining fraction. That's the probability of Khan not getting 100. Of Khan not getting 100, so the probability of none is equal to 5 out of 8, which is Khan's probability of not getting 100, times Daniel's probability of not getting 100, which is 4 out of 6. We can actually simplify before even multiplying, so we can cancel 8 with 4, and we're gonna get a 2 and a 1. We can't cancel anything in 5 and 6. Then we multiply 5 over 12. And this is the probability of both of them not getting 100. And for letter C, we are going to find the probability of Daniel getting 100 and Khan not getting 100. So we're going to use the probability of Daniel getting 100, which is 2 out of 6. So it's 2 out of 6 times the probability of Khan not getting 100, which is 5 over 8. We cancel before multiplying, or simplify. 1 over 4. So when we multiply, we get 5 over 24. So this is the probability of Daniel getting 100 and Khan not getting 100. In this project, we had to do 2 problems. We had to create our own problems related to the topic that we were assigned and solve at least an ABC question. And our topic was addition and multiplication rules in probability. And what we learned is that you will use addition rules if you want to find the probability of at least one of the events from happening out of a certain number of events that you will work with. And we use multiplication rules when we want to find the probability of 2 or more events of happening at the same time. We did 2 problems. One was with the grade in test question, in which we had the probability of somebody getting a certain grade, and we multiplied that times the probability of the other guy getting the certain grade to see what was the final probability of getting what we were trying to find. And the first problem for addition, which was the problem related to students who studied statistics or calculus. We tried to find the answer to the questions using addition rules.